So what are you guys?
We're the Swartwood family.
So are you guys real Swartwood MCAT students?
Hell yeah!
Hey guys, this is John from Swartwood, and although this is not my usual thing, my wife and I just had our second baby, so in order to get these videos out, I think it's easier if we try this format. Let's go ahead and add supplement. So this is a supplement to the Barron's book. So in that problem, the very first section, we talked about, I think, exponents, logs, rules of logs, etc., etc. Why don't we do sort of a more difficult combination problem, okay? So if I look at this guy, let's say we have 1 over log of A plus 1 over log of B. Hopefully the camera could pick that up well enough. Okay. And let's say it's equal to 2. And they give us a couple of conditions. So 1, they tell us that log of A times log of B is, let's say, 1. Okay? And then the question for us in this case is going to be, then what is the log of A times B? Okay? So again, looking at a problem like this, I think maybe one of the first things to do is look at what we're going for, which is log of A times B, right? And look at what we're given, which is, of course, the problem setup, but then this guy. So I'm kind of thinking, like, how does this guy figure into this, right? So I'm thinking maybe one of the first things we should do is work this left-hand side and see if we can get it to look more like one of these two guys, okay? So obviously if I want to add fractions, I want to get a common denominator. Maybe the nicest one here, the easiest one, would be log of A times log of B. Do you guys agree? But if I want to do that, then I need to multiply the left-hand side of this setup by log of B, or the left fraction, right? Top and bottom. And, effectively what I'm doing is just multiplying by 1. So if we do that, we get up top, log of B. And then for this guy, same thing. Just hit this guy top and bottom by log of A. Okay? And then we'll get up top plus, because it's connected by plus, right? Log of A. Okay. So that's the equation so far. So now it's looking much better, right? Because they give us log of A times log of B is 1, and the bottom is definitely log of A times log of B. So we'll just do a direct substitution, right? Log of B times plus log of A over 1, it's going to be 2. Okay. Okay, which really just gives us this guy, right? Log of A plus, sorry, I flipped the guys, but it's the same thing, right? Log of B plus A is log of A plus B. Okay, is equal to 2. And then the final thing is we're going for this guy, but we're given this, right? So there's got to be some sort of relationship. And in this case, it's a usual log thing. So that's why this problem is kind of an exercise with logs, because, the thinking is log, right, represents, let's say we're talking about these exponents here. Logs represent the exponent in a way. So they're representing what the little guys do. So if the big guys multiply, like 2 squared times 2 to a third, the little guys add. So we're going to work that. So if the exponents are being, well, let's look at this guy. So if the guy inside, the big guy is being multiplied in some sense, right? Then the exponents are being added together. So log of A plus log of B, by that log rule, is actually log of A times B. Okay? And so literally, there you have it. So log, just to say it again, of A times B is definitely 2.